Well, we're going to start a new unit today, Unit 9 on real numbers and right triangles. A lot of good information in here. We're going to start off with the idea of square roots, which you guys have had since your middle school days. Square roots here, notice I set up a little mini times table because when we think of square roots, we think of perfect squares. Perfect squares are those numbers that are the square of an integer. 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5. Because the idea of a perfect square and a square root go hand in hand. Here, in fact, is a definition. A square root of a number, which we'll call n, is any number m such that m squared equals n. So we're able to square the number, we get the n here. So if I look at and know my perfect squares, then I'm going to know my square roots. And I'm going to show some examples of that in just a moment. Also remember that every positive number has two square roots, one positive and one negative. Primarily up to this point, you've been just studying the positive square root, sometimes called the principal square root of a number. But we're going to talk about that in a little bit more detail. The radical sign, which you see here, which is primarily just this first part of this symbol, that's just kind of a grouping symbol here, represents a non-negative, which means it could be either 0 or positive, non-negative square root. So when you see that, we're not looking at a negative square root, we're looking at a positive one. So we're going to remember that symbol for the radical sign here. And of course this little symbol, the plus or minus, refers to both square roots. So when we put that in front of the radical sign, we'll be looking at a positive and a negative value. And of course the one trivial one is that 0 has only one square root, and that's itself, because 0 times 0 is 0. So it's really important to know your perfect squares. I'm going to give you a list here in just a second of some of your perfect squares, and then we'll use that to evaluate square roots and also to approximate square roots. Okay, here are some examples. We'll start off with the basic ideas of the positive and the negative square roots. Now notice that I'm taking the square root of 25. 25, of course, is 5 times 5. With this symbol, we want the principal or the positive square root of 25, and that, of course, is just 5. Now, if I put the opposite sign in front of the radical, then I'm taking the square root of 25, the principal or positive square root of 25, which is 5, but I'm taking the opposite of it, thus I get negative 5. If I put the plus or minus symbol in front of the radical sign here, then I have plus or minus 5, because I want both values with that. Now look at the example here. It says find the square roots of the number. Now notice it says square roots. There are going to be 2 of them. So I have to know my perfect squares. Here's 36. I know 36 happens to be 6 times 6. So it would be plus or minus 6 for my 2 square roots. 121, a little bit tougher, but you probably remember that as 11 times 11. So the 2 square roots of 121 would be plus or minus 11. The last one, maybe you're not as familiar with, but 20 times 20 is 400, so the 2 square roots of 400 are plus or minus 20. Now I've got a list here of 14 perfect squares. If I had spaced this out a little bit better, I was going for 15, but I took too much space down on this end. 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6. This is a good list to have perhaps in your notes so that you can refer to them as you're working problems out. And it goes all the way up, as you can see here, to 14 times 14. Now I'm going to use those to work the next 3 problems. It says approximate each to the nearest integer. There is no nice neat number times itself that gives me 67, but I do notice that 67 and 64 are very close. And I know that the square root of 64, the principal square root, it's the positive, would be 8. So I'm going to approximate this as 8. Okay? The little squiggles like that means it's approximately. Same thing here. The square root of 23, I try to find a perfect square since 23 is not a perfect square. I try to find a perfect square very close to 23, and that would be 25. Of course, that's 5 times 5, so this is approximately 5. The last one, the square root of 125, again, it's very close to 121, right? 121 is 11 times 11, so this is approximately 11. Now, if you have one that does not come out evenly, like the next example, and they want it even more specific, they want a better approximation, And then as you can see in the directions, you need a calculator. So I grab my calculator. It says use a calculator to approximate the square root of 632. So I have to use the square root of 632. And what I'm going to do is I'm going to punch out my answer here. And I'm going to write it out because I'm to round to the nearest tenth. Well, on my calculator I get 25.13961018. They don't want all that. They want it to the nearest tenth. That's this spot. So I look to the right. It's less than 5. I round down. I don't need any of this. And I have 25.1. That's a point there, believe it or not, even though I'm smearing it. 0.1 as my approximation for the square root of 632. Okay, now we're going to solve equations using square roots. It says here, solve each equation, round to the nearest tenth if necessary. Well, it's not going to be necessary on the first problem because we have a number squared, x squared, equals 36, and we know 36 is a perfect square. So what I'm going to do is I'm going to take the square root of both sides. I'm going to take the square root of x squared. I'm going to take the square root of 36. And I'm going to get x equals plus or minus 6 because there are two square roots, one positive and one negative. Very similar on problem part B here. I'm going to solve for y. Now in this case the y squared is being multiplied by 4, so my first step would be to divide both sides by 4. I get y squared equals 33 divided by 4, which I could change to a decimal or a mixed number, but here is where I'm going to take the square root of both sides. So since I don't have a lot of space here, I'm taking the square root of this side and the square root of this side, and I'm going to get plus or minus again because I'm going to get two values here, but now I've got to get my calculator because I don't think this one's going to come out evenly. So I grab my calculator, I take the square root of 33 divided by 4, and I'm going to round to the nearest tenth. I get 2.8722 and so on. So that's going to round to 2.9. So that's going to be approximately 2.9. So I get y equals plus or minus two values, positive or negative, 2.9. Now it's positive or negative, but it's just force of habit. I say plus or minus. If I do say that, I apologize. It's positive or negative. All right, now another definition here, a radical expression. Now believe me, I taught in the 80s. This was a tough topic to talk about in the 80s. A radical expression is an expression that involves a radical sign. Not much of a definition. But I have some examples here, and I have some variables mixed in under the radical sign. By the way, I mentioned that this is the radical sign here and that this is a grouping symbol, sometimes called a vinculum. Okay? Now, I'm going to evaluate these expressions by substituting the values in, doing the arithmetic under the radical, and then taking the square root. So in this case, now notice no plus or minus or no opposite signs. These are going to be positives. I plug in, I get the square root of 12 plus 4, which is the square root of 16. Well, I don't need a calculator here. That's going to come out to be exactly 4. Positive 4, because I am looking at just the positive square root. Now I'll plug in over here. This is going to be the square root of, plug in for b is 4, and then I'm squaring that, and then I'm subtracting 12. Well, 4 to the second power is 4 times 4, that's 16. So this is the square root of 16 minus 12, which is the square root of 4. And again, don't need a calculator here. I can do that one in my head. The square root of 4 is 2. One last one with a little bit of a twist. There's a constant out in front. That means it's going to be times whatever this expression turns out to be, because when the number is right next to the radical sign without a symbol between, it implies multiplication. So this is going to be 3 times the square root of, AB means 12 times 4 plus 1. Well, 12 times 4 is 48 plus 1, that's the square root of 49, which we know is 7. So this is 3 times 7, or 21. And again, didn't need a calculator there. Now, if you're not really sure of your perfect squares, then that's why you should have that list that I gave you earlier to refer to. Otherwise, you're going to have to depend on a calculator every time. The last example, I didn't leave much space, but I think I can do the work right up here. It says a construction worker building a skyscraper accidentally drops a bolt from a height of 500 feet. Using the equation d equals 16t squared to determine the time t in seconds that it takes the bolt to fall to the ground below. So I have d equals 16t squared. I'm going to substitute in for the distance 500 right here. And this becomes a problem a little bit like the one to the right. I am going to have to divide both, I'm solving for t, I'm going to have to divide both sides by 16. Looks like I'm going to need a calculator because I know 16 does not divide evenly into 500. I grab my calculator. I'll just go ahead and leave it as 500 over 16 for now. I'm going to take the square root of both sides. Now, be careful. We're talking about time, not plus or minus. I'm not going to have negative time. I'm not in the twilight zone here. I'm going to get a positive value only, so I take the square root of 500 divided by 16. And I get 5.59, I'm going to round to the 10th. I'm going to go with 5.6, so it's going to take 5.6 seconds for that bolt to hit the ground, and I certainly wouldn't want to be standing underneath when that thing hits and possibly hit me. Alright, that's the iron hats that they wear. Alright, now, square roots are going to be an important topic in this entire unit, so make sure that you work the problems out, make sure that you ask questions if you're unsure, and of course always practice, practice, practice.